Okay, well, welcome to Project 7 hint video. It's actually the solution video, part 2. We may have more than 2, I don't know. Let's just see how it goes. Here's my form in my project, and I want to show you that I've got my labels here and I've described them and named them based on their position. Here's label top left, top middle, top right, middle left, mid right, label, as you can see here, bottom left, bottom mid, and bottom right. That's not the only way to do it. That's just the way I did it. Now, my system's not perfect either because there's no AI component to this. So a lot of times, like in the first video you saw where X one in two different directions, the reason that occurs is a flaw in the algorithm. Now, it's not perfect, but it solves some of the problems. I mean, like I'm saying, this is an intro class, in no sense in trying to throw a bunch of AI stuff in there. But the reason that happens is it all depends on which way I chose to check for the winner first. If I had chosen columns first, that may not have happened in that instance, but it could have happened in another instance. Just so happens, I think I checked rows first. I'll show you when we get into the code. So that's a sort of a flaw, but it really doesn't matter because at least it eliminates the possibility of showing X's and O's winning. And it also cuts the game off in most instances. So let's go look at the code. The first thing I want to tell you about is regions. Now I use regions extensively to keep my code more manageable. And what all that is you see how you can expand and contract some of the things that they have in here? And you could do that with your event handlers too. I like to group all my stuff together. If I've got a function and it's really big, I like to group it together using a region. Now, these properties are just variables, is what they are for this class. And when you click on it, you can expand it and contract it. Now, all you have to do is at the top of your area, type in pound region and then the space and then give it a name. And then you have to come down here and type pound in region without space. So anything inside between those two will be collapsible. So here I've got a Boolean variable called got winner, set it equal to false. And I've got my 2D answer array. Okay, there are 3 rows and 3 columns. And I'm setting them equal to a space just to initialize it that way. So when I want to get rid of that, I just click on the little minus sign and it collapses it, and it shows that that's where my properties are. In a real, complicated program, you'd have tons of properties for classes, and so it's just better to get in the habit of doing this. I'll even do it for something like an exit button, just so that it all looks the same. Here's my new click button event. I've got it in a region. Here's my place choice method, and I have it in a region. As you can see, it's rather large. Okay. And then I have, collapse that, the check winner method, and it's rather large. So in order not to have to scroll through tons of code just to get somewhere, maybe deleting opening closing braces accidentally, it's just, to me, it's easier just to put everything in its own little spot. So you can see that the code is relatively clean at this point. All right, so you saw that I had 2 class level variables. One was my 2-dimensional array and the other was the winner. Just shows if you have a winner, it's true. If not, it's false. It's just a Boolean. So I've got my new button, new game click event handler, which comes from this button here. And notice I've changed the name a little bit. I was going to put a little frog icon on there. I couldn't find one that would fit. So tic-tac-toed. So let's look at the new button. They're going to click that to start a new game. All right. So what we have here is typical event handler. And what I'm doing is I'm even if it's the first run, I'm emptying out the text label, the label text properties. Like so-and-so started first and so-and-so won, those particular labels. Now this is a for each loop. For each loops are good because you don't have to know a lot about the objects, but it's read only. You can't update things in it. but it will let you loop through controls. And because the this pointer points to the current application, every control on that form, the particular form or in that application, is in a list. It's called control list. So what I'm saying here is for each, there's my child control in the parent controls, and that's got buttons, everything in it, scroll bars, whatever. I just want to loop through there, and if that control is a label, which is all I care about in this particular instance, I don't care about buttons or the form itself. I want to reset the background color, okay? And that's what I'm doing. And so control, and this could be, if you were to look at this CTRL, once this starts, it's going to look at every label on that form, and it could be, label top left, but I don't really care at that point. I just want to go through all of them. So I'm looping through them all, and if it is a label, because there are other controls on the form, ignore it unless it's a label. If it's a label, reset everything to the color back to black, because when we get a winner, I'm setting the color to red. If we get a tie, I'm going to a different shade of red, and so forth. So I want to change it back to black and empty out the text property of that control, because I don't want to X's or zeros for a new game. I have to wipe it all out and set it back to its beginning state, and that's what we're doing here. So there's reset the color back to black and clear the 2D array. Now, I realize on the first run, this is all superfluous, but I don't care. I mean, it takes milliseconds to do this. It doesn't really matter. But we are going to have to do it after the first run anyway. So clear the two-dimensional array. And I've got my rows and my columns, and I'm just resetting it back to its initial state. And if you come up here to properties, you'll see what I'm doing. I'm just setting it back, resetting it back to that, restoring it. And even though it's that already on the first run, again, it doesn't really matter. And I'm resetting the got winner Boolean value to false, because if it's not the first run, we had a winner. We're doing another game, so we need it to be false. Now I'm calling my place choice method. And let's see what place choice is. It is a void function, meaning it is a non-value returning function. I'm passing in the max number of rows, the max number of columns, and the number of tiles. Now, you could say, well, you can just multiply max rows times max columns, get the number of tiles. Yes, that's true. I could have done that, but I didn't. So, and there's some flexibility reasons. I get in the habit of doing that because you never know how you're going to use this. You might expand the game where it's more than 3x3. Maybe it's a 4x4 or an 8x8. I mean, who knows? You could reuse this in a lot of different applications. A minesweeper game, which you might see in the future, something similar to that. Okay, so execution at this point jumps down to here, and it's passing in 3. So there's 3 rows, 3 columns, and 9 tiles, okay, which is the standard board. And here's the max index. Now, let me explain what I'm doing here and why I'm doing it. I'm converting this two-dimensional array into a one-dimensional array, and there's a reason for that. It's a simplicity reason, but you will see this quite a lot. So in order to do that, you multiply the rows times the columns and subtract 1 because it's off by 1, right? This is 0. You start at the 0th index. So that gives me a linear one-dimensional array with the same number of indices as the two-dimensional array, okay? That's a very simple concept. And this is just a little counter or incrementer, setting in it, initializing it to 0. Okay, so the first thing I want to do is figure out who's going to get the first turn. All right, well, you got to flip the coin, and to do that, you just use a random number between 0 and 1, right? And I just made a decision that if you look down here, 0 is going to give O the first turn, and 1 will give X the first turn, right? That's all that's happening. So I'm generating that, storing it in number, and then I'm taking number and converting it to a Boolean, because you can't just stick a number into a Boolean value. You have to convert it. So I'm using the convert.to Boolean. Now, how does that work? Well, here's a little ditty for you. If you didn't know this, you were about to learn it. True in almost all languages is non-zero. It could be 55, 63.2. If it's not 0, that's considered true under the hood. If it's 0, it's always false. Okay. So that's why I'm doing that. So I get a number, it's either 0 or 1, and I convert it to a Boolean because there's only two states to a Boolean, true or false. Well, 0 would be false in this instance, and 1 would be true. And so this is setting the Boolean player flag here. Okay. Here I'm creating an array of random and unique integers or numbers. Now, this is why I wanted to convert that 2D array into a 1D array with the same number of indices. This, I just Googled it. I mean, this is a really cool way of setting unique random numbers but it only works in a one-dimensional array. At least the one I found, and I didn't want to do a bunch of research, so this is what I'm doing. So I've got a little temporary array here called CAnswers, and it's a single-dimensional array of characters, right? And it's got 9 slots in it. So I'll show you when we get going here why this is so easy to use, because if you were to loop through that two-dimensional array and start trying to put numbers randomly that represent the index, it could get to a point where it really slows the program down. And this is probably written in Assembler or C++ or whatever. So this is just a class that's available to us. So that's what I'm doing. Now what happens is it goes through here and randomly sets the index to a number between what? 0 and 8. So, and you'll see what that's for in a minute. It's just a really good way of doing, to me, of doing random numbers in an array. Okay, so here we go. So I'm making this, initializing this, and then we're going to display in that label who got the first turn, which we have to do. As we said, 0 is going to be the O's and 1 is going to be the X's. Now, it says here, if Boolean player. Now, why don't I have if Boolean player equal true in here? Because it's just an extra step. If this is true, it will be non-zero. If it's 0, then it's going to be false. That's the only reason I did that. You could just as easily put Boolean player equal 1 here. It's the same thing. It's just a little shortcut. All right. So if it's not 0, it must be 1. So that since we said that 1 equals X, we put X move first in our label. Otherwise, it has to be O move first. All right. So that's all that is. Notice the comments. I had to come back here and look at this again because if I hadn't put these comments in there, I'm probably completely lost. All right, so now we're going to place the players at the generated indices. And since this is a one-dimensional array that we're pulling the indices out of, I'm going to loop from 0 to 8 and increment by 1. Here's a little index that just a little temporary variable here. And there's my temp array. All right, my temp array has got those indices in there. So I'm starting at index I in the temp array, which is really 0 because I starts out at 0. Whatever number is stored there, that's going to be the actual index that I'm going to stick up an X or an O in. Okay, so now here's my X and Y. We're going to convert back temporarily to the two-dimensional aspect, and then we're going to stick an X or an O at that location. So in order to do that, I have to have my one-dimensional array number, and then I'm going to do it like this. This is just a division. This is an integer division. The index that I got out of my temp array, and you'll see how this works as we step through it. I know it's kind of vague right now. You divide that by the max number of rows and use the max number of columns. You do a modulus to get the remainder. That gives you your X and your Y indices in your 2D array. So that's how that is done. You'll see this all over the place. That's the formula for it. Up here, I converted it to a one-dimensional array with the same number of indices, and down here, I'm calculating out, the X and the Y, or the row and the column, if you will, however you want to do it. So, depending on who the player is, if Boolean player is true, that means it's X. So at that XY location, we're going to stick an X. Otherwise, at that XY location, we're going to put an O. And then we're coming down here to check and see what index we're at. So if we're at index 0, or the upper left corner, right? If it's the player's X, then I'm going to put an X in there. And I stick my X in my answer array. So these are parallel, essentially parallel to one another. Else, it must be an O, still, so here's what I was talking about where I had two X's winning. This is one of the reasons. Because it's possible, depending on how you set this up. I mean, I'm doing the upper left. I think I'm doing rows first. I believe that's what I'm doing. Yeah. All right. Well, if it's not index 0, then let's check and see if it's 1. Okay. And if it's 1, that means that we're at the top middle. Okay. So if you go back here, we started looking here first. Now we're looking at this one. If you match these up to the array, and that's what I'm doing. Okay, there are different ways to do this. You don't have to do it this way. Maybe there's an easier way. I'm sure there is. You may have a more elegant way. All right, so we're checking that index. Again, if it's an X, I'm putting it in there. If it's not, I'm putting an O in there. We're checking the next index. It's only going to be one of these indexes for every pass. Okay, so we go all the way down to 7, and if all those are false, it has to be what? Index 8. Okay, I just didn't test it because there's no need to at this point. That's what it has to be. Notice label bottom right. I'm setting it to X if it's the player is the X, or O if the player is the O. Got something out of whack here. There we go. Now what am I doing here? Now all that's going to do is put an X or an O in one spot. This is the first pass. All right. So I'm flipping the turn at this point. How am I doing that? Well, it doesn't, using this code, using a not operator, I don't have to worry about, nor do I care if it was true or false before. It's just going to flip it the opposite. So I'm just saying Boolean player equals not Boolean player. So what that means, if Boolean player was false before, it's now going to be true, and that flips the turn. Or if it was true before, it's now going to be false, and that flips the turn. Okay, so at that point, remember I told you that what you have to do here, every time, or my method, what I did was every time I put a character in there, I'm going to check for a winner, right? So I've got a method here and a method called check winner. And then I've got this Boolean here. If I got a winner, that'll be true. Otherwise, it'll return false. So let's go to check winner. Down here. Notice that this is a value returning function, returns a true or false, a Boolean. Takes no arguments. Okay, so I go down here and I'm checking for a winner. So I check the rows first, and I'm checking all three of them, and this is basically your 2D array, and I'm counting the X's and the O's. All right, so for column 0 to less than 3, which is 0 to 2, I'm checking to see if I've got 3 X's. I'm counting my X's and my O's essentially, right? So if that's true, if X count equal 3 and got winner equals false, that means, I hadn't had one before, then it looks like I got a winner, and I'm going to change some colors and do some stuff, and so here's my label, X wins, right? Or O might get it. So yeah, I'll let you kind of go through this, but essentially I'm using the system.drawing.color to change this text. That's how you do it. It basically it's a hexadecimal value, but we use these properties to set it with. And then I'm setting got winner equal to true. So I'm going through and checking all the rows, and if I don't get anything there, I'm checking the columns. Okay, same method. All right, then I'm resetting this back. I got Boolean set to true. Boolean got winner is true. Otherwise, if it's false when I get down to the end, I know I didn't have a winner. And then I've got check right diagonal, and this is the code for that. And all I'm doing is just using the indices for that. You can see that it's 0, 0, 0, 0 here, 1, 1, 2, 2, and then the opposite direction will be 2, 0, 1, 1, 0, 2. It's just going the other direction in the diagonal. All right, a lot of ifs, but it's not difficult to do. Again, setting the colors based upon whether I've got a winner or not. If I have a winner, I'm returning true back to my processing function from which this was called. In other words, I'm returning false. So let's go back up here and close this, minimize this. If Boolean got winner equals false, that means it's a tie game. So in other words, it's going to go through that entire thing, right? And it's going to put an X and an O there. And it does it for all the labels or all the indices in that 2D array. Okay? And if it's false at the end, that means it was a tie game. No, there's no winner. Okay. Otherwise, it will have already flagged the winner. So let's run this thing and see how it works. Let's make sure that I got a breakpoint in here. I probably don't. I need one. Okay. By the way, if you haven't noticed this yet, if this is minimized, you can't change any code. If it won't let you change code, and this happens all the time because you forget that you got it in debug mode, just look down here. If you see this little icon, then go up here and stop debugging. Then you can change your code and recompile it. But all right, so we're in debug mode, and I'm going to click New Game, which is going to fire this event, right? So let's do that. Where you at? There you are. Okay, so it's going to do some housekeeping here. I'm going to press F10 to step through. It's going to reset all the colors back to black, even though this is the first run. We don't care. It's a millisecond worth of work. If this were a real labor-intensive, a processing-intensive game, you'd want to optimize it at every possibility. We'd be doing it differently anyway. So it's looping through all the controls. Now it's going through and cleaning up the array. All right, I want to jump down to here, so I'm going to put another breakpoint. I'm going to press F5 because what that will do is run to the next breakpoint. So let's do that. All right, see it stopped there. Now when I press F10, it's going to jump to the function call. Place choice. All right. Here's temp array. This is I've already calculated out how many indices I need, and I've done the random stuff. You can look at that. Temp array is null at the moment. Let's see what it does when I call that function enumerable range that I told you about. This is really cool. And again, I didn't come up with this. I found it I Googled it. All right, now let's look at temp array. You can expand it down here. And I added that to the watch window. Notice that I've got, this is going to be different every time. These are all unique values between the minimum and maximum number of indices. So there are 9 indices, or 0 through 8. So you have 7, 8, 2, 5, 4, 0, 1, 6, 3. It just does it for you. It's much, much more efficient than you trying to loop through and do that. Because if you loop through that, you have to examine and see if you've used that number before. And when you start getting down to you've got 1 or 2 slots left, it can get processor intensive. This is so much quicker and just does it, and you don't even have to worry about how it works. Okay, so let's go ahead and step through. There's my temporary C answers. Oh, that's characters. See who got the first. Who the first player is. It's false. So what does that tell you? That tells me that it must be O. Okay, so let's function F10, and it's saying it's just putting a text in the label 0 move first. And now we're going to put the players at the generated index, and here we go with the temp array. So what it did was it's looping through temp array starting at index 0 right here. The index stored there. So this is an array that simply stores the index of an array. That's all it does. So it's going to be 7 because it's pulling it out. So int index should now be 7 once that runs. And it is. So now we're going to take that information and convert it back to our x and y coordinates for our 2-dimensional array. So we're in sync with that. So is Boolean player 0 or 1? It's 0, so that means it's O, right? Now let's go and look at that array. So there it is. Notice at that index, because we recalculated it back to x and y. So at 2, 1, which was 7 in a 1-dimensional array, I have placed my O. And so now I'm going to go ahead and put that in the label, corresponding label. So basically, those labels are a 3 by 3 2-dimensional array. They equate to that. And so I've set it up that way. The only interim process is to generate a random number into a one-dimensional array. The reason I had to use a one-dimensional array is it won't do it in a two-dimensional array. So I had to come up with that, but that's neither here nor there. You can Google that kind of stuff. All right, let's go ahead and step through. Now, index is currently 7 in the one-dimensional array, right? So it should come down here and be true at 7. That's going to be O because Boolean player is false, right? So it's putting that there on that label. So bottom middle gets the O. And let's flip the turn, checks for a winner. We're not going to have a winner. Let me just F5 through that. Now, so it's went through and done everything, and it's checking again. So it put another one in there. Let's see if it'll show up. Sometimes you have to refresh it. It's not going to show it to me, is it? Sometimes when it's in the middle of something like this, it won't show you. I'm just pressing F5 so I can get to the end of all. There it is. Okay. So once it got a winner, that ended the game, right? And you can see here that I've changed the color of this, and it didn't go all the way through because, you know, we had 3 O's in a row. So I can go to new game, and if I do that, it goes back up here and reinitializes everything. I won't get through all that, but I do want to stop this long enough. Now, if you're not using the debugger, you need to learn to do that, all right? And I've introduced it a little bit, but basically you come over here to this gray bar and you can just put these what are called breakpoints here, right? And you can put these variables in what's called your watch window. You can't do that until you're in debug mode. At that point, you can. So let me show you. I'll press F5 to start debug. And click the game, and now we're in debug mode. And if I wanted to put something in my watch window, which I've already got some stuff in here, and you can take a lot of this stuff out. These X's mean that these are in another method, and you can't see them until you get in there. As far as C# is concerned, they have method level scope, so they don't exist in other methods. That's why it says it doesn't exist. Now that'll go away once I get into that method. Let's say I wanted to add number here. Where am I at? Let me go to the next function call. There we go. Place choice. All right. Let's say I wanted to add something and go up here and see what I got. Number. I would just kind of, you can hover over and look at the number at the value stored there too, but I'm going to right click on it and go to add watch. When I do that, it shows up down here and it shows me the value is 1. Okay. 1 gets converted to a Boolean, which 1 is not 0, so it must be true. That means that Boolean player is going to be true, which means it's going to be the X player. That's how I do that. Okay. So learn to use these this debugging tool. I mean, it's very, very powerful. So let me stop debugging, and I'm going to remove all my breakpoints. Delete all breakpoints. Yeah, I want to do that. Now let's run it. I'll run it and play with it. Like I said, it's not perfect, but you know, for what it is, it's fine. So press F5, new game. 0 wins in the diagonal. New game. 0 wins in the horizontal. 0 wins in the column, the vertical. X wins in the column 2, excuse me, row 2. X wins diagonally. O wins horizontally. Oh, I have a tie game. See that? Now change the colors. All right, so let me go back and go to code view and make sure you can see what I've got here. And you could stop the video and look at it. Remember now, you have to, if you're going to have an event handler, don't just type in what I've got here. You actually have to go to the form and add that event. If you type it, it'll work. I mean, it won't give you an error as long as the syntax is correct, but it hasn't tied that button click event to the event handler and the code behind. So this won't work. I've seen that before. You actually have to add the event and then put the code in. Okay, so remember that. Now these are custom methods, so you don't have to worry about any events for that. But the click events for buttons and things like that, you have to actually add those. So there's all of that. Now remember, put these regions in. It's very, very powerful. And here's my place choice method. And I'll slowly scroll through, and you can pause the video as you need to. And I'm converting the 1D index to the X and Y for the two-dimensional index. When you put the debug stop breakpoints in here, you'll see what I'm doing. The only reason for this is so that I could use this class right here, the enumerable class. And as far as I could tell, it has to be a single dimensional array. But if you put the code in there to do it yourself, you can do it, but you have to check and make sure that each number is unique in that array, so you don't have 2 7 indices or 2 3s. Well, as you get closer and closer to the end, it's like kind of like a bubble sort. It gets slower and slower and slower because you keep having to generate another number, and you probably already hit that one 50 times. This just works so much easier. But the takeaway from it is I have to go from a one-dimensional array to a two-dimensional array and back and forth. But I've showed you the code for that. Mathematically, it's very simple. And there again, this is probably bloated, but it works. I didn't look at theirs because I don't think theirs will work as good, but that's just my opinion. All right, and there's my check winner method. And I'm setting the colors. I check the rows first, and then I'm doing the columns, and I'm doing the diagonals, and I'm setting the colors and all that kind of stuff. I'm setting the got winner stuff, returning whether it's true or false. And there's my exit button, which obviously you don't need to see that. But I'm going to close all this up one more time just to show you why these regions are so useful. Because when you get a big program, if you're using these regions, you can just breeze right around in this code, and you don't have to sit there and scroll through line after line after line of code. See how clean that is? Alrighty. This should get you to the finish line. And I know this one's a little complicated, but you know, programming's not easy, but we got the logic out of the way. And I've showed you the code, so you should be able to copy it and finish it without a whole lot of effort. All right, I'll see you at Project 8.